Welcome back. Like I mentioned on the previous recording, on this part of the lecture, we're going to continue using Lewis structures, but we're going to use it now for covalent compounds. Compounds where you have a non-metal combined with at least another non-metal. And different to the ones that we did earlier, different to the ionics, where you have to transfer an electron becoming a cation, and the element that is gaining the electron becomes the anion. For the covalent compounds, they actually are going to share those electrons, so each one of them will be like an overgas with 8 valence electrons, or 2 for helium and 2 for hydrogen when it gets an extra one. So let's practice to see how we're going to do this. So let's do pH3. The way I like to do this is by usually the first element is going to be the center piece. So phosphorus will be on the center, and we're going to try to distribute the hydrogens around it. Nature likes symmetry. So that's what I like to distribute the hydrogens around it. In addition to that, we know that the Lewis structure for hydrogen is like this. So hydrogen can only make one bond. So if you ever see something like this, that's what I like to call a monstrosity, because hydrogen can only have one bond, the same way that nitrogen, for the most part, so there are always exceptions, right? For the most part, can only have 3 bonds. So having electrons on pair or electrons by themselves is what makes the element reactive, because that's where it can form new bonds. So back to pH3 of phosphorus trihydride. So, so what I like to do is, I know that phosphorus have 5 valence electrons. Hydrogen have 1 valence electrons, and there's 3 of them in this case. So altogether, I'm gonna have 8 electrons. So what I'm gonna do, I'm gonna put 1, 2, 3, 4, 5, 6, 7, and 8. So I use every single electron that I have. This is a compound, so I'm gonna bring this closer. And I'm gonna make sure that each element is like an overgas. So hydrogen have 2 electrons, just like helium. So it's like an overgas. This hydrogen also is like helium. This hydrogen is also like helium. And the phosphorus is like an overgas with 8 electrons around it. So with the 8 electrons that we had to play with, we were able to make every element in the compound happy. So that's how we know that we had the proper Lewis structure. Notice that these electrons there, we count those for the phosphorus, and we also count them for the hydrogens, because they are being shared, therefore a covalent compound. So on covalent compounds, the electrons are accounted for each element because they're being shared by those 2 elements. Let's do the next one. Oops, sorry. For the next one, we're gonna have sulfur and 2 chlorines. And from the periodic table, sulfur we have 6 valence electrons, chlorine we have 7, each one of them. So all together, we're gonna have 20 electrons to play with. So the first element, we put it on the center, and then we distribute the other 2 around it. I'm gonna start with 1, 2, 3, 4, 5, 6, 7, 8. And then let me bring this closer, sorry. 8. 10, 12, 14, 16, 18, and 20. And when we do it like that, you can see that the chlorine is like an overgas. The other chlorine is also like an overgas. And the sulfur is also like an overgas. So with the 20 electrons that I had to play with, I was able to make every element stable like an overgas. Let's try another one. Let's try fluorine. So fluorine, which is a diatomic molecule, is gonna have fluorine and fluorine. Fluorine have 7 valence electrons. So altogether, we're gonna have 14 electrons to play with. As you may notice, there's no central atom in this because there's only 2 of them, so nothing is central atom. So what I'm gonna do, I'm gonna say, well, 14 electrons, so 2, 4, 6, 8. Let's bring this together as a compound. 10, 12, and 14. When I do it like that, this one we have 8 valence electrons, and this one have also 8 valence electrons. So this one is okay, and this one is okay. By the way, every time you have electrons that are being shared, that's what we're gonna call a chemical bond. And we're gonna represent it with a line. So this would be another way of doing a Lewis structure for fluorine. And HI, or hydroiodic acid, we're gonna have hydrogen with 1 electron, and iodide, which is a halogen with 7. 1, 2, 3, 4, 5, 6, and 7. So the hydrogen is like helium, which is an overgas, and the iodine is like an overgas also, with 8 valence electrons, like all the elements of group 18. Let's practice some more, because this is a very important concept. We're going to be able to predict a lot of the properties by understanding how to do the Lewis structures, then doing the shape, then looking for the polarity. So oxygen, so this one is a little bit different. So I'm going to have 1 oxygen combined with another oxygen. From the periodic table, we know that oxygen has 6 valence electrons. So altogether, it's going to be 12. So we're going to put 1 oxygen there and 1 oxygen there. And we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we're going to say, so this is like an overgas. But this one is not like an overgas. So this one is okay, but this one is not. This one only has 6 electrons. So how are we going to fix that? Well, the way we're going to fix that, we're going to take these 2 electrons over here, and we're going to get rid of them, and we're going to put them in between. So let me fix this a little bit. So instead of having only 2 electrons, we're going to have 4 electrons. That way, this will have 8 electrons, and this one will have 8 electrons also. And we're still dealing with only 12 electrons. So whenever you don't have enough electrons to make everybody happy, start moving electrons in between the 2 elements until you can share everything and everybody can have 8 with only the amount you have. So the way we represent this is by doing oxygen with 2 bonds. Every 2 electrons is what we call a bond, and then the rest of the electrons will go like this. So this is what we call multiple bonds, where you have more than 2 electrons in between the actual elements, the electrons that are being shared. So let's do carbon monoxide. So carbon monoxide, we have carbon, we have 4 electrons, and we have oxygen, we have 6 electrons. So altogether we have 10 electrons to play with. So we're gonna put the carbon there, the oxygen there, and we're gonna go, and the reason I'm putting 2 electrons at the same time is because I know it's gonna be full at the end. So I'm not gonna do it by one because at the end it's gonna be full. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the carbon is okay. The carbon have 8 electrons around it, but obviously not for the oxygen. So how are we gonna fix that? We're gonna do what I said before. We're gonna take these electrons and put them in between. That will tell me that the carbon is okay with 8 electrons, but the oxygen still have only 6. So I am not done yet. I need to try to do something more. So I'm gonna take 2 more electrons and I'm gonna put them in between. Now, this carbon will have 8 electrons, and this oxygen will have 8 electrons. So you see how I have to move stuff around in between the elements until everybody have 8 electrons without adding anything more than 10 electrons. The other one is a little bit more challenging. On the other one is telling us that nitrogen is going to be the center atom, and that the hydrogen is going to be bonded to one of the oxygens. So nitrogen is on the center, the oxygens are going to be on the sides, and there's going to be a hydrogen attached to one of the oxygens. That's basically what they told us to do. So oxygen have 6 electrons, nitrogen have 5, the other oxygen have 6, and this one have 1. So that would be 12. So with 18 electrons, we're gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 18. So when we do it like that, this one is okay, that one is okay, this one is okay like helium, but this one is not. So once more, we're just gonna take these 2 electrons and we're gonna put them in between. So when we do that, we're gonna have 8 electrons, 8 electrons, 8 electrons, and 2 electrons. So everything is right. And let's do the last one. On the last one, we're gonna have sulfur is on the center. I'm gonna put oxygens on both sides. And we're gonna have 6 plus 6 plus 6, which is gonna be 18 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 12, 14, 16, 18. We can see that this one is already okay. This one is okay with 8, but we're missing 2 there. So once more, we're gonna fix it the way we want it. We're gonna take these 2 electrons and we're gonna get rid of them by putting them in between. That way, 8 electrons, 8 electrons, and 8 electrons. So this will be sulfur, double bond, oxygen, single bond, and oxygen. And that's how we do the Lewis structures. If by any chance we have something like this, for example, OH negative, we're going to have 6 electrons plus 1 electron plus 1 more electron. So use the charge for the total number of electrons, which is going to be 8. 2, 4, 6, and 8. So the oxygen is good and the hydrogen is good. So whenever you have an ion, if it's negative, add that many electrons. If it's positive, take those electrons out. For example, if I have ammonium, that would be 5 plus 4 minus 1 because it's positive. So that would be 8 electrons. So I will do something like this. 1, 2, 3, 4, 5, 6, 7, 8. And it's an ion, so I will put a positive charge there. And that's how we do the covalent structure with Lewis structures. So you should be able to do that now. You should be able to also do that one. And with that, we say that we have been exposed and pending more practice on your part. Now you know how to do Lewis structure for covalent compounds. So that will be it for right now. So see you next time. Take care.